Hello everyone, welcome back to our channel Indra Educational Academy. In continuation of data structures, you see we are in the fourth unit of that paper of Andhra University based syllabus, and in fourth unit we discuss about non-linear data structures. That means trees and graphs. Trees and graphs are the examples of non-linear data structure. So let's begin our class with the concept of tree. So here tree is a data structure which contains nodes. Each node is an element and add its right and left nodes. Binary tree is the most common used tree. So here in previous we learn about the linear data structures, which is array, linked list, stacks and queue. Now we are going to learn about non-linear. Non-linear means unsequential data. So here trace is also not in sequential, it is also in unsequential, either left node or right node. So here it is the syntax for that binary tree. Here once check, the root tree have two trees, one left tree, one right tree. So example of that. And intersecting elements into tree, how the user adding elements in the binary tree. So this is the process of that adding elements or values to that binary tree. Once check all these 4 points ma. Next, tree consists some concepts. Those are node, degree, leaf, siblings, ancestors, leaf height and depth, forest, root node, parent, child, subtree, visiting, transversing keys. So all these are some concepts of the tree. In similar to understand the tree concept, we have to imagine tree as a family. In human family, humans have siblings, cousins, parents, grandparents, aunts, uncles. All those relations are there for human. So like that human family only, here binary tree also classified. So what is those? Node, degree, leaf. So coming to node is the each element in a tree along with the address and address of left and right node is called node. That means it consists of both the relation with the left node and right node also. And degree, the number of subtrees of a entire tree is called degree. Leaf is nothing but a nodes having 0 degree called leaf. That means in right in right node. So here leaf indicates a node which have no child node is called as leaf. And siblings, siblings are the same children, sorry, siblings are the childrens of same parent node is known as sibling. And ancestors is the root node. That means starting node is known as ancestor. And level of node is the level of node is how it describes me one and its children comes under to the level. That means it's like generations of humans, father, son, grandson, like that. Here levels are described. And height, it is the maximum number of levels of node including root node. Next, forest. A tree without root is called forest. Without root node, it is impossible to construct the binary tree. Next, root node. The node at the top of the tree is called root node. That means the starting node. Parent node. Any node having any other node linked from its top is called parent node. That means a node which have another subnodes, then that node itself becomes the parent node. Child node, that means derived node from another node. Subtree, any node may be considered as root of the subtree. It has child is known as subtree. Next, visiting is checking the values of each node, transversing to visit each node in a particular order. That means either from right side or left side. And keys, the key value is used to search the items. So these are the main concepts binary tree. And Next one, implementation of binary tree using array. So by using arrays, that means by using linear concept, we are implementing the non-linear, that is binary tree. So this is the process ma. Once check all these and read that one. Next, advantages of binary tree and disadvantages of binary tree. Here formula for parent location equal to child location minus 1 by 2. These are the disadvantages of binary tree. And implementation of binary tree using linked list. So in previous I told, using arrays and linked list only representation is occur. So this is the linked list. In previous, linked list is nothing but nodes. So these are the advantages. Another most, binary search tree. So here binary search tree is a binary tree either empty or having a node whose key satisfies the following conditions. Either the tree is empty or it has some keys, that means it has some satisfy some conditions. So for example, a tree is given, it is empty, there is no subtree, then it is comes under to the empty. So that such trees are known as a binary search tree. So here following conditions are given. The key in the left child of header precedes the key in the parent mode. The left or right subtrees of the roots are again binary search. The key is the right child of node and the key in the parent node. Once succeeds means increasing, precedes means decreasing. So if the left child of a head is decreasing in the parent mode or parent node, so that condition, and left or right subtrees of root again binary search tree. That means left and right subtrees or also again become binary search tree. And key in the right child of node succeeds the key in the parent node. So here the key in the right child is increasing the key in the parent node. All these three conditions are satisfied by any tree, then that tree comes under the binary search tree. So here we can transverse binary trees in three ways: pre-order, in order, post-order. So coming to pre-order, visit the root of the tree, then come to the left subtree, three or then went to the right subtree. In order, first to check the left subtree, then root, then right. Whereas coming to post-order, left subtree, right subtree, then last root subtree. Once check these graphical representations of that in order, pre-order, post-order. This is the example, and this example is very important. This concept is also very important in examination. The board will give one graphical representation like that, and they're asked to write pre-order, in order, post-order terms. So you have to write like this. Next, operations of binary search tree is intersecting a node. Intersecting a node is nothing but adding a element to that either left node or right node. Example, and deleting a node. The deleting node can be done in three ways. That if it is happen in leaf node. This is the example of that. And if the node has one child, then it can also be deleted. If the node has two children, it is also be deleted. So all these three conditions supports the deletion of tree. Next one is threaded binary tree. A threaded binary tree is similar to normal binary tree, but the difference is null pointers. So binary tree without threading. Binary tree using linked list without threading, one way threading. And next one is heap tree. Heap tree is one of the type of binary trees. First binary tree, next binary search tree, next heap tree. So coming to heap tree can be divided into two types based on their order. So mini heap property, that means each node is greater than or equal to its parent node. That means here once check 7 and 12 are greater than the root node, that is parent node, which consists the value 6. Next, maximum heap node. Here the value of each node is less than or equal to parent node. That means 15 and 10 is less than the value of 17. So these are that. And applications of tree is also very important ma. Trees can hold objects that are located by keys. The operating system maintains the files and folders in a tree structure. Trees are used to represent phase structure of sentence. Along these advantages or applications, we can write your own examples also, or mean your own applications. Applications is nothing but uses and benefits only. So this is the entire topic of unit 4 of data structures using C. So in closing of this topic, once check what are the topics we discussed in this. So firstly, tree definition and advantages and disadvantages of the tree, and next one is coming to types of tree. We discussed about a binary search tree and a heap tree. So before going to that, we discussed some important topics of that tree: root node, parent, child, all these are comes under this some topics of that. And implementation of binary tree using array and implementation of binary tree using linked list, these comes under the representation of binary tree ma. Next, binary search tree is one of the search tree, that means one of the classification of search tree. So this is the transversing pre-order, in order, post order, very important for second sem students of Andhra University syllabus. So this is the example. And operations of that binary tree. After operations, threaded binary tree is another type of binary tree. Next one is heap tree applications. So up to here we completed. So in unit 4 we completed introduction to binary tree, types of trees, basic definitions, properties, representation, operations, binary tree transversals, applications of binary tree. All these are completed in this unit 4 of data structure using C. So this is the unit 4 of second sem of Andhra University based syllabus. Thank you for watching. For more knowledgeable videos and information videos, please subscribe to my channel. Jai Hind.